Okay, thank you very much, Eva, for your invitation. It's a really pleasure for me to join, to meet with you, and to spend this, I hope, 1 hour together. My name is Agnieszka Tubis. I represent Wroclaw University of Science and Technology, and the area of my research is risk assessment, digital transformation, sustainability development in transport and in logistics. The topic for today, which I prepare, is digitalization of public transport in cities with the example of selected transport system. As you can imagine, it's Wroclaw transport system, of course. This is a plan of my presentation. I base today on 4 points. I will start from 3 pillars of the future cities. Then I want to say you something about maturity models, especially digital maturity models, because it is the topic of our of my presentation today. The main point of my speech is digital maturity model TRAM. It's a model which I prepared with my colleagues, and this model is dedicated for TRAM systems. And last but not least, I want to show you some results of our research connected with use this DMM-TRAM in our tram system in Wroclaw. The current discussion on urban development is based on 3 pillars: sustainability, digital transformation, and building resilient city. Therefore, when preparing development strategies today, decision makers are focusing their attention on creating sustainability solution using technological advance to make city more resilient to various kinds of adverse events. And now we start for the most important topic for us today is, of course, sustainable city. The concept of sustainable city is based also of 3 pillars: social, economic, and environmental. Therefore, sustainability research focus on creating cities that enable all its inhabitants to meet their own needs now and improve their well-being without harming the environment or threatening the living conditions of others today and in the future. Research trends related to the concept of sustainable cities focus on issues concerning resource management, green infrastructure, social inclusiveness and participation, adaptation to climate change, compact city, 50-minute city. We have such lectures 3 weeks ago, if I could remember, technology. But for us, of course, the most important are this area connected with sustainable mobility, and this area focus on aspects connected with promotion of public, low carbon, and accessible transport, reduction of car traffic in the city centers, low and better zero emission zones, development of pedestrian zones, development of cycling and scooter infrastructure, and of course implementation of sharing economy models. In relation to smart city concept, the attention of researchers has focused on the role of technology in urban development And for this reason, alternative terms for this concept can be found in literature such as digital cities or intelligent cities or information cities and sensing cities, for example. In this regard, many researchers emphasize that the concept is a vision of urban development that aims to integrate multiple IT solutions to better manage city resources. Increasingly, however, the research for this area emphasizes sustainability, efficiency, and quality of life, with technology being only a tool for the implementation of projects related to this technology. Therefore, the literature review conducted indicates that technology is, of course, the mainstream research related to the smart city concept, but research trends related to and include important aspects of urban life, such as smart environment, smart living, smart citizen and government, and smart infrastructure. Also, in this concept, one of the main research trends is transport, especially smart mobility, and research conducted in this area concern of intelligent transportation systems, Internet of Vehicles, smart traffic management, vehicles tracking, today autonomous vehicles, very popular AI and machine learning algorithms to navigate, but also to reduce the risk of accidents, but also digital platforms to connect passengers with drivers, for example. The biggest challenge of the coming years is to strike a balance between climate change and building and managing urban resilience. Urban resilience refers to the ability of the cities and their systems to adapt the dynamic changes regarding social, economical, environmental, but also political situations. The concept also integrates different approach, how cities prepare for and respond to emerging disasters or extreme events. Therefore, one of the main issues addressed in research in this area is the impact of climate change on critical urban infrastructure and on urban planning. However, resilience is also assessed in terms of the adaptation of critical infrastructure networks to changing conditions and threats, organizational resilience, economic resilience, and communities resilience. An important component of critical infrastructure of resilient city is urban transport systems, especially public transport development. Resilience is building on resilient infrastructure, but also on the use of public transport as part of crisis management system. The importance of this concept is confirmed by the literature reviews, which show an increased number of publications related to each of this concept. As you can see from the graphs presented here, the last decade has been the period of intense growth in research related to each of these concepts. The largest number of publications is in research related to sustainable city. Since 2016, we have increase in the number of papers related to this topic. And the second important point was year 2024, which characterized by an intensive increase in publication. A second critical research trend is use of digital transformation in the development of contemporary urban systems. Industry 5.0, Industry 4.0, 5.0, technological development are generate a lot of tools to support decision makers and improve the quality of life, of our life in the city. For this concept, we have two peaks generating an increase in publication. The first is 2017, and here we have a doubling of the number of publications relative to papers that appear in 2016. And the second intensive increase in publication is 2090, sorry, in 2019, followed by same stabilization. The youngest concept is city resilience, of course, which has been developed by research primarily since 2018. The intense interest in city resilience can be seen primarily in the development of research in the last 3 years. This trend was obviously influenced by the COVID pandemic, but also by the nature disaster, for example, floods, that have threatened many largest cities in recent years. Why I have presented all three concepts to you, rather than focusing only on the smart city aspect, which is the main topic of my presentation today. For the past few weeks, we have been talking about sustainability in these meetings, and in the background of this concept, there are issues related to both smart city and building city resilience. Why it is so important? Because we talk about a vision for urban development in Europe today, and we are aware that sustainable cities are cities that use the potential of new technologies to manage, for example, green infrastructure more efficiently, support social inclusivity, and assist citizens in participatory urban governments. We are also increasingly aware that the climate change adaptations that are being implemented are not only creating climate neutrality strategies, but also developing infrastructure to strengthen resilience to flood or high winds, for example, or droughts. Therefore, as we begin to discuss sustainable cities today, we need to be aware that these are at the same time cities that are building their resilience based on the digital transformation. The topic we are focused on today is, of course, the maturity models used to assess the level of digital transformation in urban transport system. But before we move on the main point of the program, it is important to explain what maturity models are and why we develop and use them in the industry. We have some definitions of maturity models. Maturity model is a set of tools and some good practice that enable the assessment of the organization's management competencies. And at the same time, we can use it to identify of objectives and related changes aimed at its development. We currently use maturity models to assessing the level of fulfillment of some standards. We can use it to measure selected areas for monitoring the current state, but also to some benchmarking analysis with other organizations, for example. We can use it to define development directions for organization based on requirements formulated for next maturity levels. And we can use it to identify the organization's strength and weakness, for example. Several maturity models are currently being developed, dedicated to different areas of business activity and considering different concepts and development trends observed in industry and environment. But the most popular maturity model is capability maturity model, which is used to improve processes by improving the efficiency of selected components. The framework of this model has influenced the software development companies and the direction of research related to software process improvement. CMM is recognized as one of the more practical maturity model approaches. Although initially designed to improve processes related to software development and information systems, it evolved and it proved to be so universal that it became the leading model used to diagnose business process maturity levels also in other sectors. The CMM model is, I think, very helpful tool in implementing process orientation in organization, as it provides some roadmap for the required activities, initiatives and projects aimed at the process development of the organizations. The framework of CMM model is based on 5 maturity levels, as you can see on these pictures. Now this model is some standard for newly developed models. The analysis of the guidelines presented in numerous review publications on the development of maturity models make it possible to identify the main elements that comprise the model framework. In my opinion, the most important element is subject of assessment, and here we can assess object or process or some concept or systems or trends. We should identify some dimensions. And usually we identify for 4 to 16 dimensions, but usually it's 8 to 10 dimensions. These dimensions is area which are the most important in our opinion, which we should assess in our model. We define some levels of our assessment in our model, and usually we have 5 degrees. Level 1 is usually the base level, and the highest is the 5, and it's usually we define this level as optimal level for our model, but it's not necessary that it should be 5 levels. I show you today my model, and this model has only 4 levels of in the framework. Very important elements of when we prepare the model is maturity principles. We decide how we want to assess this maturity, and we have here usually 2 models. One is continuous model, in which the maturity level of the assessed object is measured based on the average level of the maturity achieved in every individual dimensions. And the second model is a stage model, in which all areas of the given level must be achieved in order to move to higher level. In this model, the value of the lowest level of fulfillment in the some dimensions determines the maturity level of whole organization or whole system. And the last important aspects when we prepare model is the assessment mode. And here we can use some independent, so-called self-assessment model. We can prepare some research paper, and the organization can alone prepare the whole research. But many researchers suggest that better situation is when we have some external auditor in this process. Digital transformation in industry is defined as a process that consists of several phases leading the company to achieve this digital world's requirements in a perfect way. And in this way, we can use a digital maturity model. We can define these models as constitute structure methodologies that integrate assessment tools and best practice to evaluate, but also we can support the formulation of development goals and the identification of necessary changes. The use of digital maturity assessment models can contribute to increasing the individual enterprise readiness to use advanced digital technologies at all levels, which should be considered. And the purpose of the maturity model being developed is to provide means to assess the company's current maturity to implement industry measures that will help the organization reach a higher level of maturity to maximize benefits. The use of DMM in practice allows managers to provide an estimate of the current capabilities and the maturity of the organization and general directions toward the desired maturity level. Research findings indicate that most DMM models are characterized by the following features. DMM frameworks are developed on principles similar to this of CMM, which I show you on the earliest slides. The analyzed parameters are always the assessed dimensions and maturity levels. The assessment is done in several areas, as I show you in the next slides. Each maturity level has a specific name and define requirements for each assessed dimensions. In some models, the maturity level is expressed quantitatively using a readiness index. And most DMMs are holistic in nature, and this is some of the lack which many research notice in their publications. DMMs are currently being developed by both academics and many consultancies. The number of models and publications related to their development and implementation is growing every year, as you can see on these pictures. The first publications related to these models appeared in the Scopus database in 2016. But the most important year is 2020 because in this point we can observe that the number of publications starts to grow up. Yes. I also prepare some digital maturity model, which was originally dedicated to the evaluation of logistics processes, but I adopt this model to the specifics of different transport systems, for example, for inland transport and for urban transport. And I have included publications related to it for you in the materials for these lectures. Sorry. As I have noticed, we have now a lot of models connected with digital maturity, and that's why some researchers have taken up the challenge of assessing their merit and practical applications. Research by Carilla, among others, of course, has proven that the models currently described still need to be continuously improved. Among their most important limitations, Carrillo pointed out the lack of assurance of methodological rigor in the designing of the model framework, and the situation we have usually in models prepared by consultancies. But on the other hand, the lack of empirical studies to validate the model under real-world conditions, and the situation we have, of course, in models prepared by researchers. And the last lack is connected with consideration of sector or supply chain specificities in formulating requirements for the defined maturity levels. Taking this limitation into account, we planned our research according to these research procedures, which you can see on these pictures. And it took into account not only our theoretical research, which aimed to ensure this excellence in the content, but also research on trends related to digital transformation in the sector, which are also very important in our analysis. In this way, we ensure that the previously indicated constraints 1 and 3 did not occur in our model. In addition, in order to confirm the practical usefulness of the developed tool, in the last research step, we carried out a verification of the model in a real tramway system, and the results of this verification I will also present today. In our model, we assess 4 levels. This digital maturity we assess at 4 levels. Level 1 is basic and is characterized by lack of integration of data and transport service processes. And we have also a low level of digitization in this situation. The second level is developmental. Here we have some standardization and integration of selected components of the tram system and the digitization of the fundamental processes involved in its operation. Level 3, advanced, we have a predictive system, and this system are introduced and access to large data sets in digital form and support of their management process using digital tools. And the last level is leader, and we have full digital maturity of the tramway system, realizing the full potential of technological development by integrating individual system components and implementing the digital good practice in all stages and levels of management. when we built the DMM model framework, we relied on our theoretical knowledge, of course, regarding creating DMM models and the formal requirements related to their development. However, using our practical experience in this research was equally important for us. Magdalena and I worked for several years at the urban transport company, which manages tram in Wroclaw. And Mateusz worked at the Wroclaw city office, which is responsible for organizing public transport. Thanks to this, we know the aspects of the functioning of tram system from different point of view, and this allowed us to take a broader look at the problem of this research problem of digital transformation in the system. And based on this, we can develop a comprehensive assessment tools, I think. For this reason, the framework of our model is based on 5 assessment dimensions, 5 assessment areas: personal management, information management, passenger flow management, infrastructure management, and operation risk management. These areas are divided into several sub-areas, and for example, in personnel management, we have 3 sub-areas: improving skills, operational preparation for transport tasks, and operational preparation for city traffic, for example. And in dimension operational risk management, we have 2 sub-areas connected with a measurement of performance indicators and reporting of emergencies situation. I will not present all these characteristics here because I think it's not necessary. I'm including here an example framework for the selected sub-area connected with information management. However, if you would like to learn more about the framework of this model and perhaps use it in the preparation of your thesis, our article will be published soon, in which the whole model described in detail. As soon as the article is available, I will add it to my catalog in Unite Meta Campus. We have choose because in this main elements which I show you earlier, we have one important decision connected with maturity principles, and we have in this topic 2 models. In our model, in our DMM-TRAM, we chose the continuous assessment model to assess the global maturity level, which means that the system assessment is the average maturity score obtained in all assessed sub-areas. There is no need for the system to meet the requirements of all areas at a given level to obtain a higher level of maturity, and we assume that this digital maturity may be very different between individual subdimensions. Our model is dedicated tool for assessing the current state of the system. We can identify the current level of digital maturity in the whole tram system, and also we can use it to set a direction for future development of the system based on the defined requirement for next maturity level. We use this model to assess the tram system in Wroclaw, and in our research we use the following methods. We use face-to-face interviews with managers and also with operational staff. We observed the process, we observed the whole system, how it operate, how the people, how the managers make decision, which tools they use, and so on and so on. We prepare some process analysis. We check all procedures. We prepare functionality analysis of digital systems in use in all stakeholders, and we assess inventory. Our tram system comprises 24 tram lines. A single urban operator is responsible for service. The operator owns the vehicle fleet and is responsible for its operation and maintenance. The operator has also managed the track infrastructures, including its maintenance for several years. This operator's name is MPK, Wroclaw. And the transport organizer is the transport department in Wroclaw City Hall, and this department is responsible for commissioning transport service to the company. And the tram stop infrastructure is managed by a separate urban company whose task is to maintain the platform. You can see, I think not all, but usually use trams in our city, and this is our tram connection in our city when you want to visit Wrocław in the future. I hope so. We conduct a comprehensive assessment of all areas included in the model, which is what the results look like. As you can see, the system meets the highest maturity criteria in some areas, such as locating vehicles, for example. However, the system was assessed at the lowest level in some area. The results obtained are important information for managers. They receive information about the strength and weakness of the assessed system. They could learn which business area require immediately action and development plan. Additionally, thanks to the characteristic of the individual maturity levels, they receive guidance on what actions should be taken to achieve a higher level of digital maturity. I hope that managers who received for us these results use it to improve our city system. I hope I have interested you in the digital transformation of urban transport systems and digital maturity models. As I said, today's research results will be published in a journal soon, and I will add it article to our Meta Campus library as soon as it will be possible.